Hi everyone. Today we're going to continue our discussion on ions and specifically ionic compounds. So remember, ionic compounds will consist of a metal and a nonmetal, and in fact, it actually consists of positive and negative charges that are held together by their strong electrical attractions. So remember, opposite charges attract. Now off to the right we have the example of table salt, which is an ionic compound. So if we could zoom in on table salt, we would see a very crystalline structure. So you can see that we have kind of a square shape there that's formed. And if we could zoom in on that even further, we would find alternating sodium ions and chloride ions. So in the picture below, the sodium ions are represented by purple dots or purple spheres, and the chloride ions are represented by green spheres. And we call this sodium chloride. Okay, so let's talk about some properties here. So ionic compounds consist of positive and negative ions. So a metal ion and a non-metal ion. So ionic compounds have attractions called ionic bonds between those positively charged metal ions and the negatively charged non-metal ions. Additionally, ionic compounds have really high melting points. So for instance, if you try to melt table salt, it takes a lot of energy, a lot of heat. But also ionic compounds are solids at room temperature. So if we think about table salt, we know that that's a solid at room temperature. And that's pretty true across the board for ionic compounds. So really, ionic compounds have really strong bonds that are hard to break. All right, so talking about sodium chloride again. This is actually a really explosive reaction. So if you try to make table salt just from pure sodium and pure chlorine, it's very, very explosive. I was going to put a YouTube video in here, but it wasn't working. So, but if you look up sodium and chlorine reaction on YouTube, it will show a really bright reaction. So kind of fun to watch. So remember, neutral sodium is very explosive, very reactive with water. So basically what you do is you put a little bit of this pure sodium into a container that holds chlorine gas. And then you just add a little bit of water and it starts the reaction, and the sodium atoms are going to transfer an electron to one of the chlorine atoms. And you end up forming positively charged sodium ions, negatively charged chlorine ions, and then you form sodium chloride. So let's look at that in a little bit more detail. Okay, so down below we have a neutral sodium atom and a neutral chlorine atom. And again, sodium has one valence electron because it's in group 1A. Chlorine has 7 valence electrons. It's in group 7A. And sodium can actually give its one electron to chlorine. So there can be a transfer of electrons here. And remember, when sodium loses its valence electron, it becomes positively charged. And when chlorine gains an electron, it becomes negatively charged. So this works out great because positive charges and negative charges attract. So sodium and the chloride ion are going to attract each other and form an ionic bond. All right. Now, when we're writing out a chemical formula for an ionic compound like NaCl, we want to make sure that the symbols and subscripts are written in the lowest whole number ratio of the atoms or ions. But also, we want to make sure that the sum of ionic charges in the formula is equal to 0. So down below, we have a little algebraic equation here, or just a simple summation. So we have one positive charge and one negative charge, and they cancel each other out to make a neutral compound. So we don't want to write, for instance, Na2Cl2. That's not representing the lowest whole number ratio of the ions. So in an ionic compound, we're going to assume that the compound is neutral, that its overall charge is 0. So within the compound, the total positive charge has to equal the total negative charge. Okay. Now, what if we don't have a simple one-to-one ratio? What happens here? So, for instance, we said previously that magnesium has 2 valence electrons. And what if magnesium wants to form a compound with chlorine? So we just said chlorine only needs 1 electron to have an octet. So what happens here is magnesium is going to give one of its electrons to one chlorine atom, and then it will give its other electron to another chlorine atom. All right, so then what we have is a magnesium ion with a 2+ charge and 2 chloride ions, each with a -1 charge. So if we look at the mathematical expression down below, we have one 2+ charge, but we have 2 1- charges, and when we add those together, they balance out so that we have an overall neutral compound. Okay. So the way we would write this chemical formula is MgCl2. So we would use a little subscript 2 to show that there are 2 chloride ions for every 1 magnesium ion. So remember when we were balancing equations and we said that you do not change the subscripts? This is why, because let's say we needed 4 chlorines or something. If we write MgCl4, that's not an accurate representation of the ratio between the magnesium ion and the chloride ions. So that doesn't work. We cannot change subscripts once we have written them down to show ionic ratios. Now, what if we're going in the opposite direction? Let's say we have sodium, which has 1 valence electron, and it wants to form a bond with sulfur. Well, sulfur is in group 6A, so it has 6 valence electrons, which means that it needs 2 electrons to have an octet. So what's going to happen here is one sodium atom is going to give up its electron to sulfur. So then sulfur will have 7 valence electrons, so it still needs 1 more electron. So then another sodium atom can come in and give sulfur its last electron there. So we end up with 2 positively charged sodium atoms, and then a sulfur ion with a 2- charge. So we would write this as Na subscript 2S. So that's showing we need 2 sodium ions for every 1 sulfur ion. Okay, and then we have a neutral compound. So let's go through a quick learning check. We're going to select the correct formula for each of the following ionic compounds. So let's do the first one together. we have sodium plus and O2 minus. So what is the correct ratio between those two ions to make a neutral ionic compound? Okay, so we have Na plus, we have O2 minus. Now, if we add those charges together, we still have a negative charge left over. So we need to balance that negative charge with another positive charge. So now we have a total of 2 plus from our sodium ions, and then a total of 2 minus from our oxygen ion. Okay, so that tells us that we need 2 sodium ions for every 1 oxygen ion or oxide ion. So which formula would be correct? A, B, or C? B. So that shows we have 2 sodium ions for every 1 oxide ion. So now if you want to pause the video and try number 2 and number 3 on your own, you can. And when you unpause the video, we'll go over them together. Okay, so let's try number 2. We have Al3+, so that's an aluminum ion. And then we have Cl-, so a chloride ion. Okay, so initially if we just have Al3+ and Cl-, those charges don't cancel each other out, right? So we would have, let's see, 3 minus 1 is a 2 plus charge left over. So let's put another chloride ion there. Okay, so we have 3 plus and then a total of 2 minus, so that still doesn't cancel. So we need one more chloride ion to balance everything out. So now we have 3 positive charges and 3 negative charges. So everything cancels to give us a neutral compound. Okay, so then which formula would be correct, A, B, or C? A. AlCl3. So that tells us we have 3 chloride ions for every 1 aluminum ion. Okay, number 3 is a little tricky here. We have a magnesium ion with a 2 plus charge, and then the nitride ion with a 3 minus charge. Okay, so let's see. Let's say initially we just have one of each. So you can probably already tell that these charges don't cancel each other out. We actually need more positive charges, right? So let's add another magnesium ion, but it still has a 2 plus charge, so that does not change. So let's see, we have overall a 4 plus charge and a 3 minus charge at this point. Okay, so now we have too many positive charges. So let's add another negative ion here. Okay, so we have 4 plus and 6 minus total. So we still have too many negative charges, so let's add another magnesium. Okay, I think we finally figured it out. So we've got 6 plus coming from our 3 positive ions, and we have 6 minus coming from our 2 negative ions. So now they balance each other out. So which formula would be the correct formula, A, B, or C? C. We have 3 magnesium ions and 2 nitride ions. The other way to figure this out is trying to find a common factor here, or I guess a common value between them. So for instance, if you have charges that aren't easy to balance, what I tend to do in these situations is I just take the charge of the opposite ion and turn it into a subscript down below. So the 2 is going to come down and become a subscript for nitrogen, and then the 3 is going to come down and become a subscript for magnesium. So that's another way to do it, because essentially at that point you're multiplying magnesium by 3 and you're multiplying nitrogen by 2. So you end up with 6 plus and 6 minus. But whatever works for you. If you like to draw pictures, that's totally fine. If you want to try this method where you kind of switch the charges and make them subscripts, that's also fine. Just as long as you get the same answer, whatever works. Okay, so hopefully this helps a little bit with figuring out chemical formulas for ionic compounds. So next time, we're going to learn how to name and write ionic formulas. Naming ionic compounds is fairly simple as long as you're looking at the representative elements. When we start incorporating the transition elements, it gets a little trickier, so we'll talk about that next time.